Hello, good morning to one and all for the today's session. So I will be in this session I will be discussing about unequal arm balance. Okay. So first of all we'll discuss why we are going for unequal arm balance. Okay. An unequal arm analytical balance. Okay. Previously we have discussed about analytical balance. Okay. Equal arm analytical balance. So that equal arm analytical balance suffers from a major disadvantages. It requires a set of weights which are at least as heavy as maximum weight to be measured. So we are preferring unequal arm balance. And the unequal arm balance is used for the measurement of heavier weights with the help of lighter weights. The unequal arm balance uses two arms. In the sketch you all can see one is of load arm and another is power arm. The load arm is associated with the load and power arm is associated with power. And next you all can see this figure that mass m acts. Mass m at this end you all can see mass m acts as on the power arm beam. And exerts force fg. Fg, g is nothing but due to gravity. So fg is equal to m into g. This force acts as a counterforcing force against this force acts as a counterforcing force against the load arm, that is ft. That is a test force. Is it clear with this? Next, after that, the beam is pivoted on a knife edge q. This beam is pivoted. You all can see here the beam is pivoted on a knife edge q. This whole beam is pivoted on the knife edge q, and the test force ft. The test force ft is this test force ft. This test force ft is applied by a screw or a lever through a knife edge, this knife edge q. The test force ft is applied through this knife edge q. Now knife edge p until the pointer indicates the beam is horizontal. The test force when it is applied with the help of this knife edge p, it will be applied until the this pointer indicates that beam is horizontal. So for the balance of movement, ft force test force ft is into a. Ft into see here, this ft into this a. So we are getting here ft into a is equal to fg into this. You all can see in this figure fg into b. Next, therefore test force ft is equal to fg into b by a. Therefore ft is equal to m into g into b by a, that is equal to constant into b. Therefore, thus the test force is proportional to the distance d of the mass from the knife edge p. Hence the mass m is constant and test force is applied at the fixed distance a from the knife edge q. The setup shown in figure used for measurement of tensile force with a suitable modifications. It can be used for compression, shearing and bending forces. Is it clear? This machine can also be used for the measurement of unknown mass. Suppose force ft is produced by an unknown mass m1. Suppose the force ft is produced by an unknown unknown mass m1. So what gives here? Test force Ft is equal to m1 into g. So for the balance, what do we get here? For the balance, m1 into g into a is equal to mg into b. Therefore m1 is equal to m into b by a is equal to a constant into b. That's it. Therefore, the power arm B may be calibrated to read unknown mass m1 directly if m and a are fixed. This forms the basis of countless weighting machine. Okay. Thank you for the